2 talking about Riemann sums and accumulation functions and second fundamental theorem of calculus. Let's assume you have just taken over as a manager of a struggling umbrella company. Umbrellas are manufactured at a given rate given by G of t, 20t minus t squared umbrellas per hour for 0 to 14 hours, where t is the hours after the factory opens in the morning at 6 a.m. And that function is graphed below. Number 1. After your leisurely breakfast, you arrive at work at 9 o'clock a.m. Write an expression that gives the number of umbrellas that have been produced before you even arrived. So remember, we're just doing an accumulation function, so it opens at 6 as a 0 hour, till I arrived 3 hours later at 9. And we're talking about the accumulation of the g function, so g of t dt. Roughly how many umbrellas were produced during this time? So I'd like you to pause the video and use any method that we've used so far, or if you can come up with a new method to find the area, how many umbrellas were produced from 0 to 3 hours? So we've talked about rectangles, left endpoint and right endpoint rectangles, and midpoints, and trapezoid. We haven't really talked about this, but as I draw this line down, this is my 3 hours, I see, to me that just looks like a really nice triangle. So I'm going to use the area of a triangle to get my estimate. So the area of a triangle is 1/2 base times the height. So 1/2, my base is 0 to 3 hours. And my height is, well, however high this function is, g of 3 at 3 hours. So 3 times the 1/2, I have 3/2. And then my function, I'm going to plug 3 in for that. And when I do all this, I get 3/2 times 51. So I can see that it's 76.5. So in the first 3 hours, they produced about 77 umbrellas. At 12:30, you break for a long lunch. Now I want you to write an expression that gives the number of umbrellas that have been produced that day up until your lunch break. So again, we started at the 0 hour, and my lunch break at 12:30 is 6.5 hours after it opened. And again, we're just talking about this g of t function, so g of t dt. Now, roughly how many umbrellas were produced during this time? Again, I'd like you to pause the video and use any methods you'd like to see if you can determine how many umbrellas were produced from 0 to the first 6.5 hours. So I'm going to use the triangle that I just found. That was 76.5. Plus, then I notice that I have a trapezoid there as the remaining time. So the area of a trapezoid is 1/2. My base 1 is going to be g of 3, plus my base 2 is going to be g of 6.5, and then times my height from 3 to 6.5 hours is going to be 3.5 hours. Finding the function values, g of 3 is 51 and g of 6.5 is 87.5, and then multiplying all that together, I get 319.3. So in the first 6.5 hours, it seems that there were 319 umbrellas manufactured. Number 3, write an equation involving an integral for a function f of x that gives the number of umbrellas produced x hours after the factory has opened. So f of x, well, the same way we did before, from the time the factory opened, 0 hours to that x hour. And then again, I have my function g of t dt. And again, what we need to remember is that my function f of x is an accumulation function. We're looking for the area under that curve. Now find f prime of 8 and interpret your answer in the context of this problem. F of 8 is the rate of change of umbrellas produced at t equals 8. If you recall, my original function, g of t, is the rate at which umbrellas are manufactured at a given time. So the rate of change of umbrellas produced at t equals 8 is simply g of 8. So that we're at 8 hours, they are producing 96 umbrellas per hour. And number 5, when is f of x changing the fastest, and how do you know? This question is asking us the rate of change in production. So the rate of umbrellas per hour, when is the rate of umbrellas per hour at its greatest? So this is asking us for g prime of t, which is 20 minus 2t. When we set that equal to 0, we see at t equals 10, which is 4 pm, the rate of change of umbrellas is the greatest. And if you look at the graph, at 10, that's the point that we are making the most umbrellas. So an accumulation function outputs the area under a curve from some starting value to x, the input. Notationally, this is what we have. So when we take the integral, when we find that area, you'll notice we now use a capital F for that notation. You'll please notice that the x is my independent variable, c is my starting value, and f of t is my rate of accumulation. So a fundamental theorem of calculus is that the rate of change of an accumulation function, the derivative of the accumulation function, is d dx, also of this integral, which is in fact just f of x, small f of x. The graph of f of t is shown below to the right. Let h of x be the accumulation from negative 2 to x of f of t. Find h of 2. Well, we're replacing that x with 2, so must be we replace that x with 2. So this is going to go from negative 2 to 2 of f of t dt. And you'll notice if we go from negative 2 to 2, we're basically finding the area of this triangle. So we can use our common triangle formula. 1/2 the base is 4 times the height is 4. So the area, the accumulation is 8 units. Number 2, find h of 8. So again, we're going to go from negative 2 to 8, f of t dt. So now we're going from negative 2 all the way to positive 8. So we have this triangle. We already found the area of that was 8. This one has the same base and the same height. Oops. So that one's going to be plus 8. Plus now the area of that triangle is 1/2. The base is only 2 units. And the height of that is a negative 4 units. When I do this, I have 8 plus 8 minus 4. So the area of that region is going to be 12 units. Remembering that the area underneath the x-axis is a negative area. Part C, find h prime of x. Well, this is just referring to our fundamental theorem of calculus up above. This is simply going to be f of x. Number 2, let y be that accumulation function. Find dy dx. Again, this is that fundamental theorem of calculus, so it's simply going to be the square root of 2 minus e to the 3x. And finally, let g of x be the integral from 1 to x of 3t plus 5 of dt. Find a formula for g of x that does not include integrals. Well, we could think about the graph of this. If we think about the graph of this, if we go from 1, has a positive slope, so 1 to x. This point here, if I plug 1 into my function, is going to be 1, 8. And if I plug x in, then I'm going to have the ordered pair x, 3x plus 5. In order to find the area of that region, well, that region is a trapezoid, so 1/2, my base 1 is 8, plus my base 2 is 3x plus 5, times my height of my trapezoid is going to be x minus 1. Now I'd like you to simplify that. 1/2, 3x plus 13 times x minus 1. And when we multiply that together, we get 1/2 3x squared plus 10x minus 13. Part 2. So this is g of x. Use your answer in part A to find g prime of x. Well, that's just the derivative. So 1/2 times 6x plus 10. This is pretty easy to distribute in, so we get 3x plus 5. How do parts A and B illustrate the fundamental theorem of calculus? Well, if you notice, my 3x plus 5, the derivative of the accumulation function is the integrand. And so there's basically written out the second fundamental theorem of calculus for this specific problem. If you have any questions on this, I look forward to seeing you in class.